This is for the heart rate activity. I just finished taking my heart rate, and it's 55 beats per minute. And I want to calculate out how many beats per hour, how many beats per day, how many beats per year, and how many beats my heart will beat in a lifetime. So if I go minutes per hour over here, hours in a day, days in a year, and I need to figure out my lifetime in a year. So if I go on to, what I like to do is go to Wolfram Alpha, and you just type that in, you'll find it. Type in life expectancy of male born 1975, because that's when I was born, and I look at it, push enter, and you'll see that it's 77.85 years. So I'll fill that out and put 77.85. Just numbers. I won't give them labels, because then that Excel won't be able to compute. But if you want to figure out your percentage chance of living past 40, 70, whatever you have, and it has a little analysis on everything, the bottom part, whatever part, Wolfram Alpha is kind of neat. Does a lot of other things too. All right, so we have beats per hour. Now the best way to figure out beats per hour is just to use a proportion. And as you see, I have 55 beats per minute, and I want to figure out how many beats are in 60 minutes. So I'm going to go ahead and do a little math here. And if you look, if you remember from the Excel spreadsheet, 55 beats I had in cell B2, and then minutes in an hour was in J2. So I'm going to write that as a little note, B2, and this one is J2. So if I'm going to solve this proportion, since I have x in the numerator, I'm going to multiply by 60 minutes on this side and multiply by 60 minutes on this side. So then I cross these out. 60 divided by 60 is 1. You get x equals 60 times 55, which in turn is going to make x equal to 3,300. Now, notice what cells these were in. I had, this one was in B2, and this one here, 60, was in J2. So I can actually go back to Excel, and I can know that this one is equal to B2, and I'll just click on B2, Shift 8 to get times J2. Push enter. And there's 3,300. Now let's calculate beats per day. Notice that the beats per hour is in C2, and hours in a day is in J3. So I'll go to this one, and this one was in C2, and this one was in, J3. If I follow the same pattern, our x is equal to C2 times J3. Now let's go back to Excel. Equals C2 times J3. Push enter. Now the same problem, beats in a year, equals D2 times the amount of days in a year. Now if I want to know beats in a lifetime, equals beats per year times how many years do I live. So my heart should beat that many times per year. Now if you'll notice, if I narrow my window, see how it gives me 2.3 E plus 0.09? What that really means is 2.03 times 10 to the 9th. Gives it in scientific notation. If I expand my cell, it'll give me all the digits. I mean, if you look at it, 2.3, it rounds the 2.5 to 3, and then there's 9 decimal places. So times 10 to the 9th. So in scientific notation, this is the number. 2.252, however you would like it, make it larger. So then the next part of the assignment is to do an animal. I chose a tiger. Now, I'm just going to do a Google search. You look around, do your best and see what you can find. If I go here, I found the average life expectancy of a tiger while in 15 years in the wild, so I'm going to use the wild. So let's use 15. And if you find something, you can't find something totally perfect, accurate, that's fine. I have another one here. See how the heart rate of a tiger ranged from 56 to 97? I'm just going to average that. So, and you can do that with Excel. You just type in equals, and then I'll put it in parentheses, because I want to add 56 plus 97 first. And I want to find the middle of those two numbers, or the average of those two numbers is the same thing. I just add them up and divide by 2. It says they go range from there, so I'll just assume it's in the middle and use that. So then their heart rate is 76.5. Now I can take this cell and follow the equation down. Now let's look at this. It takes B3 times J3. Is that correct? B3 times J3. No, it's not. J3 is hours in a day, but I want minutes in an hour. How do I fix that? Oh, I think here's what you can do. You go to J2, and let's put dollar signs in front of it. Okay, so now I'm just in this cell right above, C2, and I put dollar signs in front of the J2. The J, and put a dollar sign in front of the 2. Now let me copy that down. Ah, that makes more sense. Yeah, they have more beats. Obviously, if their heart rate is higher, they should have more beats per hour than I do. So if I'm going to do that with this one, then I'm going to have to go back and put a dollar sign here too. So I'm going to put a dollar sign J, dollar sign 3. And what that does is it really makes that cell, it's a static reference. So when I fill it down, notice how this one says C2 J3, which is C2 right here, and J3, which is this one. Now when I fill it down, I'll grab this corner right here. Now look at this equation. C3, so it incremented that one like I wanted, but it kept J3. Look, it's highlighted over here. It kept J3 for me. Then I'll do this one, beats in a lifetime, but now I have to fix that one too. And fix this one. Oops. There we go. And get that one. So now I can copy this one down. There we go. Now beats in a lifetime, am I going to want this one to increment? It says E2. E2, I want it to go to E3, so that's good. And this one says J5. Do I want it to go to J6? Yeah, so I don't put the dollar sign because the tiger will have a different life expectancy than I do. So their heart would beat a lot less times than mine because their life expectancy is that many years. But now look, if I thought they wanted to live, let's do captivity, 26 years. And I put that one in there. Whoa, they're about half as much as us, so that's a lot larger. But you can just change it on the fly. If you want to change your life expectancy and do somebody else, say my life expectancy is 85 instead, I found out, or I figured out because of healthy reasons or not, boom. Or maybe my life expectancy because of hereditary things is 62 only. And I'll look at my beats per lifetime. And see how it just changes on the fly? So that changes automatically on the fly for you if you set it up this way. I can just change these numbers and the equations stick. It just calculates it on the fly for you. All right, I hope that helps with heart rate activity. If you have any questions, again, please ask.